about music.
Yeah, I was just going to present you.
Oh, okay.
You just presented yourself.
Okay, yeah.
Okay,
Yeah.
so.
And it's a pleasure to be here and to see a lot of old friends and meet some new friends as well. So, and we have a co-author who's not able to join us, Yash, who's a student at IIT at Khandelwal. Music Blocks is a microworld about music, and music is something that is part of life, part of being human. It's important in Thai culture, and it's important in Western culture as well. This is a slide from a project that I did with one of the teachers in Kamsaka, who happens to be here. Please stand and just wave to everyone. Thank you. This was really the kids playing music, and they composed some music, played music with their parents as sort of a community orchestra. It's a harbinger of some of the things we're doing today, but it's really a different approach. Music Blocks is really about, it's a microworld that we developed to really introduce kids to the powerful ideas of music. What are the powerful concepts of music that can give them some structure and some understanding so they can do more with music. It's also about programming, about cognitive development, and it's also software Libre. It's free software. We're going to talk a little bit about why we think that's so fundamental and so important. Some of it has to do with learning, and some of it has to do with the social construct of the learning and of the community. And I want to remember Marvin Minsky, who passed away last week. Cynthia Solomon, who's in a different panel right at the moment, couldn't join us for this talk today. She took this picture of Marvin 2 weeks ago. In his lap is something called the Music Box. Marvin and Ed Fredkin invented and they have a patent on the digital synthesizer. And this is the first digital synthesizer. And Marvin and one of his students interfaced that synthesizer to logo back in 1972. And when they did it, there were two different approaches taken to using logo with Music Box. And the first is sort of the engineer's approach, which is you just spit out the notes, and the duration of the notes is based on how many times you repeat it. And so Frere Jacques just spelled out like that. The second approach, which was actually developed by Pat Winston, who was a student of Marvin's at the time, said, wait a second. This is music. This isn't just a series of notes, but music has structure. Let's see if we can't expose some of the structure in the programming and expose some of the underlying tenets of music. So what he did was he wrote little subroutines each to represent a different phrase in the music, and then programmed the repeat of the phrases in the music in order to make the musical expression. So you can see the contrast between just spitting out notes to a synthesizer versus beginning to introduce some of the structural elements of music. So the idea behind a microworld is you're building sort of a small space, a play space in some sense that's bounded, but at the same time it's rich enough that the students can explore powerful ideas. And so what we've tried to do with Music Blocks is it's somewhat bounded, though there's a caveat that we're going to get to towards the end of the talk. And yet at the same time, it's very expressive. There's been some precedent in this forum of some people who've done some very interesting stuff, providing structure to Music Blocks. If we have more time to go into a little more detail of their work. But now I'm going to hand over to Devin, and Devin's going to actually start to talk about Music Blocks, how it works, and the results of some workshops we've done both back in Boston and here on Monday at school, and then we'll go from there.
So, my name is Devin Ulibarri, and I'm a musician, and I'm a music educator. I have some programs through the New England Conservatory and also at a YMCA in different communities around the Boston area in the United States. And I met Walter because I was interested in two things. I was interested in the implications of free software for education, and I was interested in teaching fundamental concepts, shared fundamental concepts of music in free software, because that's the medium that Walter's still at. So what you see here is kind of, I guess, one of our big breakthrough moments. We were actually collaborating, and Yash, who is our third author, was working closely with me to make music blocks, and we implemented a matrix, which I can show you. We needed something even more fundamental to music. And so at the top is our note value and our pitch. And there's many different ways you can define pitch, and you can even do, this is Western solfege, but we can also do all sorts of different kinds of solfege. Yes, explain it. La, si, do, re, la, si, do, re. So, we need, these two fundamental things to make a pitch. If it were just the pitch argument, it's like, well, how long is that pitch? If it was just the time argument, it's like, what are you doing for that length of time? And so this is kind of the added parameter to what we forked, which was interval part, which has a sequence of events, but not a real specified time. Okay, so what's really important to music is form, and we kept using different terms, and eventually we found out, when our terms intersected, and we were actually saying the same thing except just using different language. And so I kept calling this a chunk, and then I found out that this is called a stack from talking to Walter about these things. And so in my mind as a musician, it's nice that it's a stack. I'm glad that there's, I think it just shows that it's a shared fundamental concept that, happens in coding as well. But in music education, this is form. So if you had a verse, for example, of a song, it might repeat 4 times, a stanza. And so that's actually a concept that you must, teach, learn in a class. Yeah, so anyone can name the melody? Okay, and then, so I mentioned the matrix. And so this was my starting point when I was talking to Walter, because I wanted music software that didn't assume that the student could read music, because not everybody is familiar with music notation, and music notation has many different components to it. But I learned this from one of my colleagues at the New England Conservatory, who has used this quite a bit, and it's extremely helpful. And because when you're working with a child, like 4 or 5, and you're teaching them how to read music, you're making a lot of assumptions. You're saying, well, they can they can read X over Y, for example, and many times you don't even test if they have that level of cognitive understanding yet. So, and then on top of that, you have sharps and flats which modify the note. So there's a lot of complexity, but this just has the note that you want over time, and you can see that the pitch goes from lowest to highest, and that this is the time. And visually, maybe you don't understand what a quarter note is, but visually you can see that these are all equal lengths. And if you come to the workshop, you can explore this a little bit more. Okay, and so here's Version. So this is actually on the music box slide, which came before. This is pretty much the same thing. And we have a melodic structure. Frere Jacques has a lot of rich content to it. We have repeats. For example, each part of the melody repeats 2 times. Sol, la, si, sol, sol, la, si, sol, si, do, re, si, do, re. And then, the next part repeats 2 times, last part repeats. And then you can overlay them to make a round. So, there's a lot of things that, when you're teaching, you have to, for, exploring this, there's a lot of rich content. And so, yeah, this is what the repeats look like in the program. So, students can, change these parameters and see what it sounds like if it were 3 times, 1 time, or maybe keep this form because it's a successful form, and change the notes inside and see if they can come up with their own round that has the same structure, the same musical form. Okay, so these are what I would think of as musical modifiers. So the sharps and flats, in standard notation. So taking a pitch, taking it down in pitch, bringing it up in pitch. When there's 2 pitches inside a note plan, you get a chord, because they're played simultaneously with the same length. So you can also adjust pitch through transposition. As a guitarist, I like to think, that I'm putting a capo on the guitar. So if you put a capo at the 12th fret, which would actually be very difficult to do, you would be going up an octave. So, and it actually, one thing that is really profound to me as a music teacher is this concept, if you're teaching through standard notation, takes a really long time to get to. It could take like, 3 or 4 months, just because first you have to master where all the notes are on the staff, and then really get into that. But here it's really obvious. Okay, and so these transformations modify rhythm, and so dot takes the length, and so if you have a quarter note length, it's that length plus half its length. So it's actually a great opportunity to talk about math, multiplying the beat value. So this 4 times 2 equals, anyone know? 8, yes, thank you. Okay, so transformations in rhythm, repeats you've seen before, duplicate notes. So that would just repeat each one of these notes 2 times. So as if this happened twice. So that would be the untransformed version, but then you would, without transforming the rhythm, so, la, la, si, si, sol, sol. Okay, so, and then these are really new features that we have, but you can set the volume, you can bring the volume up, down, all things that are critical and fundamental to music. Also a great opportunity to talk about physics, what is exactly happening to the sound, the amplitude of the waveform, and also the math behind these concepts as well. This is you can do multiple voices, so you can do counterpoint. The way took me a while to understand how this was happening because I didn't understand the code. But when I finally understood what was happening, I got it. So this is a fork of turtle art. So with turtle art, each one of these turtles, would move, and you could have 4, and they would, move. They could start at the same time, for example. With music, think of them as members of a choir. And so we have, 4 members of a choir. And can anyone guess which one might be our lowest voice of the choir? Of these 4?
Negative 24.
Negative 24, yes. Okay. Okay, so you can do graphics along with the music, so you can make your turtle dance and sing. And then also, we didn't want to make this Microworld stuck within, just the interface itself. You can output into Lilypond code, which then compiles this beautiful music for you, which you can also easily, manipulate and modulate. Okay, so when we use this in a classroom, we're teaching concepts. So Prajaka, like I was saying, has repetition. It has many other concepts like transposition you can talk about. So, bring a real piece of music to your class, use this software, and we can have an opportunity to discuss these topics in depth. Okay, so some student work. This is the transformation of hot cross buns. This is my program in Chinatown. Kids are working on the program. And they seem to really enjoy it. They brought it back the next week. Also, the teachers decided they had to continue the unit. We did a workshop here on Monday, and we got some good feedback from the students, and they created transcriptions, their own compositions, discussed things like transposition as well. This is work from Google Coding. I was fascinated with this because this is actually first and a second ending in music, using an if and then statement. This incredible piece of work was also from Google Coding, and so this is the Peanuts game, Linus and Susie. And then this, since it has all the turtle art stuff, you can program things like color into it as well. Okay, so I talked about those things. One last thing, going back to the free software, what's really incredible to me is, at the end of the day, the kids have the license to, actually look at what the software is doing, look under the hood and actually see what is going on. and then they can modify it and they can share it with their friends. And that was incredibly important to me because I believe that, you know, if you give kids the license to do these things, that they'll do it.
Yeah, in fact, they did do it.
Yeah, and they did do it. And so for those unfamiliar with what free software is, we've got this slide. Yeah, you can use for any purpose. You can, so you have the source code works, you can modify it, and you can share all things that I think are really important to a classroom setting. We have many people to thank, of course, and thank you for listening to our talk. So thank you so much, and come at, what is it, 2:45?
It's on the next slide.
Oh, okay. 3:45, and you can play music blocks.
Here.
Yeah, you can bring your laptops, Chrome preferred, and thank you.
Next slide. It's in Thai.
Oh yes, it's in Thai as well. We have Sam to thank for the Thai translations. Thank you so much.
Slide, you suddenly had to accelerate because you were under time pressure. But there's a slide where suddenly, out of nowhere, traditional music notation appeared.
Yes.
And in some way, you promised it was linked with the blocks notation.
Yeah.
How does that work? That's
So-
a non-trivial nothing.
So, if you look at that, are you familiar with Lillipond software? So Lillipond is it's text-based, and so it's actually similar to. It just happens to be kind of similar to what we have here, the visual programming environment, except with text. But its main goal is to produce beautiful sheet music. So what we did, since text-based is just actually rather convenient for exporting student work, from our visual programming environment, it creates the text for the Lillipond file, and then you run it in Lillipond, and it will create the standard music notation. And so that's great because we're not confining them to just this, visual
I
program.
see it's great.
Yeah.
I'm beginning to see how it's
It,
Yeah.
One of the things we try to do both with kernel blocks and the music blocks is give the kids a place to go.
Yeah.
Kernel blocks and music blocks are waiting, not the destination. And so one of the ways we do that with kernel blocks, you can export your program into Python or into JavaScript or into Logo, text-based Logo. So it's a way out into explore these other things. And music block, we thought the natural direction to go would be into a musical scripting language. And the one we chose initially is Lillipond. There are actually others as well. We're probably going to do a C-sound export. There's actually Lillipond provides a MIDI export as well. So the idea is
So it's like a kind of, sorry, I'm struggling, but it's kind of like there's an API built into the first world, which you can map into the second.
yeah, well, it's not really an API. It's really just sort of an export. So,
Okay, I'll speak.
yeah.
So, can you, I presume you can map, because I saw some code right there, where the actual music is drawn with the turtle graphics or something like that?
Yeah, but we're not drawing. Nobody, to my knowledge, has written a turtle program to do transcription on the screen. But you could do, so for example, there's a simple way to make a second turtle. Let's make another turtle. And now when I play this,
So now we've got one turtle who's our singer and one turtle who's our dancer. Maybe you can pull the turtles away from each other so that they have.
yeah. Actually, in the high loss percentages. Simple.
And of course, you can build upon that. You know, you can make it more complex. You can put,
The music.
well, I mean, you can record the music at the moment, but I don't see any reason why we couldn't add that sometime in the future. It's just right now we're being really insistent that we start with the fundamental stuff, because if you have that, then you can really do anything. That's why, you know, we could have spent a lot of time doing sampling, but, you know, well, what's sampling if you can't do like a note, you know, value? You know, like once we have all these things in place, then you can then sample like, you know, a sound, and then you can have your own drum kit or something.
So it's going to set definitions.
Well, one of the things that I can do is, for example, I can have a drum instead of one. But we haven't built out a lot of different voices yet. We're just trying to get the core thing working reliably first. It's still a little bit buggy. Monday was the second time we've ever used it.
You know what? There's that quote where the bugs are the opportunity for learning. I'm totally okay with any bugs. So it's fine. Like personally,